So in one of my slides, I briefly mentioned short circuit, right? And how, depending on and or, right, sometimes as long as you find one condition to be a certain value, then you don't really have to evaluate the rest. For ands, right, as soon as you find a false, it's pretty much over. For ors, as soon as you find a true, pretty much over. This is actually, there's a term for this. It's called short circuiting or short circuit evaluation. So logical and logical OR operations work similarly to the and OR gates in digital electronics. So they actually have parallels to the actual hardware, right? Operations that a computer does. So yeah, lots of parallels between programming, right, and real hardware. So yeah, for our logical operators, these actually represent gates in electronics. But what we want to know is like how can this help us, right, as programmers? Well, when you use short circuit evaluation, it means the order of your Boolean expression matters. So when you get a false on your and statements on the left side, you don't have to evaluate the right side. You're done. Because for and, both need to be true. As soon as you find a false, you're done evaluating that expression. The same goes for or. As soon as you find a true in this case, then you don't have to go and evaluate the other side, right? Depending on if you started left or right side. Typically, you read from left to right though. So yeah, if your left side is true for ors, you're done. You don't have to read the right side. So choosing the correct order can avoid costly operations and prevent errors. So it's not only useful for deciphering and evaluating these Boolean expressions. As students, right, I'll give you some quiz questions. You have to do that in the coding. But for your lab, right, assignment, you're actually gonna have to design some of these expressions. And it turns out designing them in a particular order can actually make your code better. So we're gonna take a look at some examples to learn how short circuiting works. All right. So short circuit and the AND operator. So in this scenario, we check some Boolean vars before allowing content to be posted. So here are Boolean variables. We have is logged in and has permission. So using these two variables, we're going to check them. If because we have an and here, right, both need to be true in order for us to submit that post. In this case, it makes sense to check is logged in first, right, in the logic of this program. Now, why is that? Well, if the user's not logged in, there's no point in checking whether or not they have the permission because the post won't be submitted anyways, right? So thanks to short circuiting, the check for has permission can be skipped entirely when logged in is false. It prevents unnecessary checks. Um, for example, it's possible for a user to have posting permissions, but if they're not logged in, it still doesn't matter. Now, it really depends on the context of your program, right? If you find that users are typically not logged in that many times, then it's useful to do is logged in first, right? Because this one's going to yield false a lot more. So that means you'll be able to skip the second one in a lot more cases. So you have to think about, the frequency, the probability of this one being false. Has permission, right? Maybe a lot of your users do have permission. Now this not might be always the case, right? In every single login system for any company, it really depends on your particular context and scenario. But just an example, right? If is logged in is false, then you don't have to check for permissions. That's short circuiting. With the OR operator, this one's going to make a little bit more sense. It's with Wi-Fi and mobile data. So let's say you're sending a message, right? You do need a connection, right? Either to the Wi-Fi or to your mobile provider's mobile data in order to transmit that information, right, over the internet. So you're going to need one or the other. So with the OR operator, only one of them needs to be true. So in this scenario, we check some Boolean variables before allowing a message to be sent. It makes sense to check is connected to Wi-Fi before checking is using mobile data. Why might that be the case? Well, if the user is already connected to Wi-Fi, there's no need to check whether they're using mobile data. The message can be sent over Wi-Fi. Now, why would you prefer to check Wi-Fi first? Well, it's going to avoid unnecessary checks. If you're more likely to use Wi-Fi than mobile data, then you're going to probably check Wi-Fi first. Now, why is Wi-Fi more likely? Well, mobile data, it's expensive. Maybe it's slower. Maybe you have limits. So you really want to check your Wi-Fi first, right, before checking your mobile data. So this is a scenario where maybe in your code, right, if you unwrap is using mobile data, maybe it's a lot more costly in terms of money or in terms of code efficiency. Uh, Thinking about which one is more costly is going to help you identify which order is better. So if is connected to Wi-Fi is less costly, it's better to put it up front in your or statement. So is connected to Wi-Fi, we check it first. In this case, it is true, so we don't have to check for mobile data. We just move on. This whole statement is true and the message is sent. So yeah, order matters. Once we get to functions and methods, we'll revisit short circuiting because it'll make more sense when we talk about, unnecessary checks or expensive operations. Yeah, once we get to functions and methods, we'll put this a little bit more into context and provide some more concrete examples. But yeah, for now, just remember short circuiting means the order in which you put these does matter. And also the order in which you read them, right, can help you evaluate them much faster. So short circuit tips, put the most likely to be true condition first for ORs, and then the most likely to be false first for ands, because then you won't have to do a second check. Yeah, so this is basically what you want to remember. Place simpler or faster checks before more complex or expensive ones. Again, we'll revisit this once we get to functions and methods. And then use ordering to avoid potential errors like checking for null before accessing a property or method. Sometimes one condition only makes sense to check if another is true. This one will make more sense once we start designing more complicated programs.